Hi future doctors, welcome to the next class. We were discussing refraction, laws of refraction. I think first law we discussed in previous video. So second law, Snell's law. So we have to apply Snell's law. What is this Snell's law and second law? So when light travels from one medium to another medium, there are two denser. So it is going to change its path. This is going to be normal. So whenever light is going to be incident with angle of incidence I, actually it should go like this. So with the same angle of incidence I, but it is going to bend. It is going to change its path. It bends towards the normal because velocity of light is going to be changed, isn't it? Next, what will be changed whenever one medium to another medium light is going to be passing, and what is the Snell's law? We will see now. So in this refractive index of this rarer medium, let us assume mu1. Refractive index of denser medium, that is going to be mu2. So what this Snell's law will be saying means mu1 means product of refractive index of this medium and sine of angle of incident. Product of refractive index in second medium and sine of angle of refraction. Like that, how many mediums are there? So product of mu and sine of that angle, that may be incident or refraction. So from here, it is always going to be constant. So from here, so mu1 sin I is equal to mu2 sin R. Like that, another medium is there, let us say so. So there, mu3 into sin R or R I dash, R dash, like that we are going to take. So finally, mu sin I is going to be constant, or mu sin theta is going to be constant. So from this equation, we will write mu1 by mu2 is equal to sin R by sin I. Otherwise, mu2 by mu1 is equal to sin I by sin R. So what is this mu2 by mu1? So we should come to know again. So we define refractive index. What is refractive index? We said velocity of light in medium by velocity of light in vacuum. So mu1 is nothing but C by V1 they will write. Like that, mu2 is nothing but C by V2. If you want mu2 by mu1, just mu2 by. Now what is mu2? C by V2 divided by C by V1. So if you cancel C and C, 1 by V2 into V1 by 1. Otherwise, C by V2 into V1 by C. That is going to be V1 by V2. So velocity of light in one medium by velocity of light in another medium. Now what is this mu2 by mu1 we will call? Refractive index of second medium with respect to first medium. So this mu2 by mu1 is going to be equal to V1 by V2. So this mu2 by mu1 we will call refractive index of second medium with respect to first medium. So this is going to be here sin I by sin R. So from this you can calculate velocity in first medium V1, V2, V1 by V2. So that one also you can calculate. So let us assume this is air. This is glass. In air, what is the refractive index we will take? 1. Mu1 value is going to be 1. In glass, we will take refractive index of glass. At that time, how we will write this equation means. So if you forgot this equation also, no problem. Just if you remember, we can write. So mu1 sin I. What is mu1 now? 1. Sin I is equal to, so what is refractive index here? Glass. Mu g sin R. So then refractive index of glass is sin I by sin R. We are going to write, correct? So like this, you can follow blindly this Snell's law, but light should travel from one medium to another medium. To follow this Snell's law, light should pass from one medium to another medium. Now velocity is changing or not changing means velocity is changing. Already whenever medium is changing, we discussed in previous class. V is equal to, so C by mu. Velocity is going to decrease depending on that medium. Next, what about its frequency and wavelength they are going to ask. Frequency and wavelength means light travels in the form of waves, we will assume. This is one wave. Let us assume it is going like this. Same wave will be going like this, but it is bending, that's all. Therefore, wave number is not changing. Let us assume here two waves are going to be traveling. Same two waves will be traveling here also, but it will be bending. Therefore, frequency remains same. Frequency mu or f constant when light travels from one medium to another medium. But what is changing means velocity is changing. Because of velocity, wavelength will be changing. What is the relation between all these means? So in air, C is equal to mu lambda or f lambda, they will write. In medium, V1 is equal to F1 lambda, V2 is equal to F2 lambda 2. What is constant we said? F1, F2 constant. Therefore, V1 is equal to F lambda 1, V2 is equal to F lambda 2. Now, what is V1 by V2? V1 by V2 is nothing but lambda 1 by lambda 2. So, wavelength relation, velocity relation, refractive index relation, and Snell's law, how we are going to apply. V1, velocity of light in one medium, velocity of light in another medium. So, very important equation. So, every year in NEET, definitely they are going to ask one problem on Snell's law. Snell's law means one medium to another medium, light is going to be traveling. Here, air, glass, air, water, water to glass, either air to prism, air to curved surface of some material. So, among all these, we are going to apply Snell's law. So, simply you have to remember, if medium is changing, you have to apply Snell's law. Next, we will see refractive index of one medium to another medium. So, we got, what is this one we said? Refractive index of second medium with respect to first medium. So, mu 2, 1. Let us assume mu 1, 2. Mu 1 by mu 2. So, what is the product of these two? Mu 2, 1 into mu 1, 2. What you are going to get? So, mu 2, 1. Mu 2 by mu 1. So, mu 1, 2. Mu 1 by mu 2. Whichever we are saying first, that one we have to call write in numerator. And some people will write n1, n2 also. That is same. Then what you are going to get means, if you cancel all these, you are going to get 1. Therefore, mu 2, 1 is going to be equal to 1 by mu 1, 2 also they are going to ask. Next, refractive index of glass with respect to air. Refractive index of water with respect to air. Refractive index of glass with respect to water. How we are going to write means, refractive index of glass with respect to air, mu g by mu a. What is refractive index of glass we said? 3 by 2. Refractive index of air is nearly 1. Therefore, 3 by 2, that is 1.5. Refractive index of water with respect to air, mu w by mu a. Correct? Refractive index of water, 4 by 3 by 1. So, 4 by 3. So, 4 by 3 means 1.33. Next, refractive index of glass with respect to water, mu g by mu w. Refractive index of glass, how much means 3 by 2. Refractive index of water, how much means 4 by 3. So, if you multiply this 3 by 2 into 3 by 4, that is going to be 9 by 8. So, 9 by 8 means 1.1, something you are going to, isn't it? So, 9 by 8. So, on this also they are going to ask the problems, you have to apply very clearly. Now, see one simple problem on this. They have given refractive index of glass with respect to water 9 by 8. Refractive index of water with respect to air 4 by 3. What is refractive index of glass with respect to air, they are asking. So, this is mu g by mu a, they are asking. Here they gave. So, from this, if you write mu z by mu w, that is going to be 9 by 8. So, mu water by mu air is going to be 4 by 3. If you want mu g by mu a, so what you have to do here? You have to multiply these two. Refractive index of glass with respect to water into refractive index of water with respect to air. So, if you multiply, what you are going to get here? You can write mu z by mu w into mu w by mu a. What will be cancelled? Mu w, mu w. So mu g by mu a, we are going to get, so mu g by mu a is, so 9 by 8 into 4 by 3. So if you cancel, you can do the, so 3 by 2. So like that, we can do some problems on this very easily just by applying Snell's law. So next we will see small definition, optical path. Here, whenever we are seeing velocity of light in vacuum and velocity of light in medium, both are going to be different, isn't it? So in air or vacuum, VAC UUM, not VAC CUM. So in air or vacuum, velocity of light is 3 into 10 power 8 meter per second. So if you are taking velocity of light in medium, that may be glass or water, anything, depending on refractive index, it is going to be different, that is going to be C by mu. So to cover some amount of distance in air or vacuum, how much time it is taking means velocity of light equal to distance in air d naught by t naught. T naught is nothing but d naught by c. How much time it is taking means distance traveled in vacuum by velocity of light. Within the same time, how much distance it is covering in medium. Okay, so the distance covered in the medium, how much distance it is going to cover means, let us assume this is medium which is having refractive index mu. So this distance we can take x or dm. Dm is nothing but distance in medium. Again same, what is the velocity in the medium? So v is equal to distance by time, and this time and this time should be same. Therefore, this t we can write t naught in the same time. So in the same time, how much time it is going to take in vacuum, same time we are going to take in medium. Then dm is equal to v t naught. What is t naught from here? V d naught by, in place of t naught, d naught by c we can write, isn't it? So if you write dm is equal to d naught by, so this one if you reverse, otherwise we came to know mu is equal to c by v, then v by c, reverse if you do v by c, 1 by mu. Therefore v by c is nothing but 1 by mu. Okay, so in air this is going to be mu naught times of dm. So they will give, in medium it is x, in air it is going to be mu x, that is the difference. Where it is going to cover more distance means in air it is going to cover, in medium it is going to cover less distance. This is the relation between distance covered in air means vacuum and distance covered in medium, so with respect to refractive index, but this is in same time. This distance only we are calling it as optical path. In same amount of time, how much distance it is covering in the medium.